conversate
I
about this?
hadn't checked it, to be honest with you.
Because they're in Oregon.
Hey, it's for lunch, so it's okay.
Right.
It's better for him.
Yeah, we spent the last hour trying to unwad PVC out of the boom.
Oh, so you're actually working on that issue right now. Yeah, I did actually was able to talk to our warranty administrator already. I was just kind of curious how often he's seen that. It's not real common, but it's not unheard of. Said
Okay.
he'll hear about that, a handful of times during a whole year. So it's not unheard of, but
Right.
yeah, I want to get with engineering and also assembly and talk to them.
Yeah, get with the engineer and then tell them to quit it.
Yeah, do something better. Actually, the thing I can say about engineering is they do try to improve these trucks.
Oh yeah.
It's this, yeah, I can give this to them and they can look into it, and if they can find something better, great. Actually, something they did when we were in person here, every class I had, the last day there'd be a couple engineers that come in and actually talk to all the attendees, and ask them, hey, what are you seeing on these trucks? What do you like about the trucks? What do you don't like about the trucks?
Right.
There's been a couple times when they were changing something, like actually the location of the big one I remember is the location when they were changing the location of the hydraulic filter. They had a couple ideas, and it's like, oh, we got a room full of technicians down here. Let's go talk to them.
Right.
Came down and got their opinion, got their thoughts. So they do try to improve. So I will give them that.
Oh yeah. Yeah. A lot of the things, and I've only been working on these trucks a couple of years, and I've noticed several positive changes. Like, oh wow, they finally realized that's not working.
Yeah.
Matter of fact, on the newer trucks coming in, where the sensing rod, because they used to have the big compensator block that hung off the end of the rocker pump.
Yeah.
Oh my God! If you had to go out there and deal with it in the field, it was like,
Okay, good.
here, let me drag my little 1/8 inch punch out there and stack up everything where you can get to the end of the rod.
Yeah, because you don't want to bend that. Yeah.
God.
Yeah. Now that's gone. That's out of there.
Yeah, which this seems to be a much better design.
Yeah. So let's go ahead and get going here, guys. Again, I just want to give you a chance. Any questions before we get rolling on our next subject here? Next thing up is we're going to talk about nozzles. So if there's no questions up to this point, anyway, we'll continue on with nozzles. Let me share my screen here. Okay, nozzles. Yeah, this is that more the operator is going to be more interested in this stuff, but there's some things here that I want you guys to know as far as technicians. So if you get a phone call from your operators, things like that, you can address things, talk things out with them a little bit better. But nozzles, I'm not a nozzle salesman. I'm not going to even try to sell you nozzles. There's hundreds of different nozzles, different applications, different shape sizes, all that stuff. I'm going to talk a little bit about the Vactor nozzles and give you some theories, some things to apply to your trucks anyway. Some things that you can apply no matter which nozzle they're using, but just give you guys some information so you're not going down a wrong diagnostic path or anything. So some of this, I share the same information with the operators, but the parts that I don't think you guys are going to really care about, I'm going to blow through it real quick. So again, if I go through quick, just unmute yourself and ask a question if you need to. But the two primary purposes of the jetting nozzle is to clean and pull, pull it up the line to clean it. Pressure cleans it. The flow washes the material back to your the manhole you're working in. Nozzle selection, how do I select a nozzle? It really depends on your pipe diameter, the amount and type of debris, and then also the nozzle characteristics. The nozzle characteristics is more what you guys are really going to be applying in your job. But our nozzles, they come in two configurations. There's the 15 degree, the spray of it, and then 30 degree. The 15 degrees gives you more thrust, and we're going to talk about thrust in a little bit here. More thrust is going to give you climbing, going up hills, longer runs. It'll help you get out there further. The 30 degree, that water is pointing more toward the sidewalls of the pipe. So you got better cleaning. It'll shoot some laterals too. Like I said, there's hundreds of different nozzles out there. I just picked 3 of our nozzles. I want to go through a little bit of it here. Again, I'm not going to go real in depth since you're technicians, not operators. A little bit of information here I want you guys to know, and we'll apply it at the next couple slides. But the first one is our penetrator nozzle. I'm going to get my pen out here. You can see there's 6 rearward jets. What that is here on the base of it, there's 6 jets. So the water is going to be coming out the back. So 6 jets there, and then there's 1 forward jet. So there's 1 jet, so the water's coming out the front there. Okay, it comes in 15 degree and 30 degree. There's the part number for the 15 degree. It's good for cleaning and unblocking plug lines with sanded dirt. There's your 30 degree, the part number for your 30 degree, what it's good for. The next one is the sand nozzle. Where's my, here we go. Again, 6 rearward jets. So down here, there's 6 jets. And then this one has 2 forward jets. So on the nose here, there's a jet. And then on the other side of that nose, there's another jet. Comes in 15 degree, 30 degree. And just, again, as technicians, you guys can understand this. The how many jets and how big those openings are will give us flow, how much pressure we can build with that. Is it rated for 80 gallons per minute, 60 gallons per minute? So as technicians, I hope you guys have enough common sense to understand, if we have 3 jets and all those holes are in each of those jets are real tiny, small, we can't get a lot of flow out of there. But if we have 10 jets in a nozzle and those jets are just wide open, real big holes, we can get all kinds of flow. We're not going to get any kind of pressure. The third one here is a sanitary nozzle, 6 rearward jets. So again, 6 jets down here at the bottom. There is no jets out the nose of it here. There's our part number for 15, a part number for 30. I want to put that information together mainly just so the operator knows that I kind of have a good idea that, yeah, okay, there's a lot of different nozzles out there. Talk to your nozzle salesman. Talk to them what application you're going to be using those in to help determine which nozzle they want on their truck. But some information for you guys. Okay, this slide here on the right is the decal. That decal should be one in the toolbox. And if you get a Vactor nozzle, that decal is going to be on the container that nozzle comes in. The picture on the right shows 3 of the containers there. Right there in the middle, there's that part number, a part number of a nozzle. There should be 3 letters after that number. Okay, the first letter is the calling out the diameter of the hose that nozzle is going to thread onto. So if your truck has a 1-inch hose on it, I would expect all your Vactor nozzles, that first letter to be a B. Okay, the second letter is going to be the flow. And like I said, depending on how many nozzles, how orifices, how big those orifices are, is going to determine the flow we can get out of that. Most of our trucks are 80 gallon per minute. So if you want to stick with 80 gallon per minute, I would expect that second letter to be a J. Okay, and then the third letter is the pressure. Again, most of our trucks are 2,500. Some of them be 2,000. Some could be 3,000. But most of them 25. So if your truck is 25,000 psi, okay. So every nozzle that has an application where he doesn't want to use 80 gallon. If he wants 40 gallon, that second letter would be a B. Okay, easy enough to understand. With that being said, I want to explain a couple things here for you guys. So again, you're not going down the wrong diagnostic path. You get a call from your operator saying, hey Paul, my truck, I cannot get 80 gallon per minute. All I can get is 50 gallon per minute. Something's wrong with this truck. I can hit 2,000 psi, but I can't. The most I can get is 50 gallon. There's something with the truck. You have to fix it. You got to rebuild that rudder pump, whatever. You got to fix this truck. Before you go doing that, what is that second letter? What is the flow? Even if it's an aftermarket, know the flow of that nozzle. If it's set for 50 gallon, that's all he's going to get out of there. You might be able to actually squeeze 55 gallons, but it's going to be somewhere on there. So don't forget about that. You know, if they, like I said, they come to you and say, I can't get the flow, I can get the pressure, but not the flow. Find out what that nozzle is before you go tearing the rudder pump apart or trying to figure out if you have a hydraulic problem or something. Know what nozzle they have. Yeah. The flip side of that, they call you up and say, okay, my truck is rated at 80 gallon. I can get 80 gallon, great, but I can't get 2,500. The best I can get is maybe 2,000. Your truck is set up; it's capable of 2,500 and 80 gallon per minute, but I can't hit that 2,500. Something's wrong with the truck. You got to fix it. You got to rebuild that rudder pump. Whatever you have to do, fix that pump. Again, know what nozzle you have. Maybe they've got their hands on a nozzle that's 100 gallon per minute. You know, those orifices are nice and big, and it's going to let all kinds of flow, but since it's not restricted enough, we can't get that 2,500. So again, know what nozzle you have in your truck before you start condemning something wrong with the rudder pump or something wrong hydraulically. What I would suggest is get a nozzle that with it on your truck, you can hit the pressure and the flow. Keep that in your toolbox. Don't let the operators take it out. You keep it in your toolbox for diagnostics. So when the operator comes to you and says, I can't hit the flow or the pressure, great. Let me have the truck for the day. Put your nozzle on that you can attain that pressure and flow. Run the truck yourself with your nozzle. And if you can hit that 80 gallon, 25 or whatever your truck is set up for, the operator's got something wrong with that nozzle. All right. So I was actually down in St. Louis a few months ago, and they actually have a couple of nozzles they use for the whole shop. There was, 12 guys in the shop. So they actually had a nozzle they use for everyone in the shop. And I've been at places where they just, a technician will have a nozzle he keeps in his own toolbox. So something to throw at you guys to help you not going down the wrong diagnostic path. Another theory I want to throw at you guys is that the thrust going down the line, The water pressure and the flow will give us thrust to get that nozzle up the line. Okay, there's a math equation where you can, I don't remember off the top of my head, I have it in a file on my computer, but a math equation with you use the gallon per minute and the PSI, and gives you the thrust. Okay, so throw some numbers out at you. 60 gallon per minute, 1,000 PSI, you're just short of 100 pounds of thrust. Okay. The operator calls you and says, I can't get this nozzle, I can't get it going up the line. Something's wrong. Ask them what flow, what pressure. Okay, if you double that pressure, so now we're still doing 60 gallon per minute at 2,000 PSI, we're 142 pounds of thrust. Okay, so if you can get more pressure, that's doubling that pressure is 41% increase. Great, that's going to help them. Is that going to help them enough? I don't know, but it's something you can throw at the operator to help them get that nozzle up the line. The other thing is gallons per minute. So at 30 gallon per minute, 2,000 PSI, we're just short of 70 pounds of thrust. 60 gallon a minute, so you double the flow. At 2,000 PSI, we're there at that 142 pounds of thrust. We've just doubled the thrust by doubling the flow. So a couple things you can throw at the operator, but the operator is going to know, or he's going to need to know the system he's working at. Would it be better to increase the flow or the pressure? So again, just a theory for you guys to understand if you need to help the operator get up the line a little bit better. There are higher efficiency nozzles also. The bottom one here is a lower efficiency. Let me get my pen out here. The water comes from the rotor hose, comes in, and it just fills the pocket here. And it fills the pocket, and it finds its way out the orifice there, and it sprays. It works. It gets the job done. Perfect. It's doing its work. The higher efficiency nozzle, the water comes in from the rotor hose. Instead of a big pocket here, you can see it's actually directs the water right to the orifice, then sprays the water out. Okay, so just better efficiency. If you were to take a thrust meter and put it here and another one here, the higher efficiency is going to give you better work. It will give you a better thrust there. So, but you pay more for the higher efficiency nozzle. I get my laser pointer out. So, a couple points on the efficiency nozzles anyway. Something else, make sure your technician's using a leader hose. It's a black section of hose, usually 10 feet. That's going to take a little more beating than what the rotor hose will take. We're going to talk about the rotor hose next, but make sure they use the leader hose. 2 reasons: it takes a beating better than the rotor hose, and also as they're bringing that nozzle back to the manhole, they can watch that hose. Most of our trucks got the orange hose on it. Some of them's blue, but whatever rotor hose they have, they hole, and they can start powering the truck down. There's guide fin. Make sure they use a guide fin. There is a part number for the narrow one. There's different widths of guide fins, but just make sure they're using a guide fin. The purpose of that guide fin, we want it prevents the hose from turning around in that line that's being cleaned. What we want is from the hard section of the fitting of the hose to the tip of the nozzle, whatever nozzle they're using, we want that distance greater than the diameter of the pipe. Okay. If it's longer than that length of longer than the diameter of the pipe, then it can't turn around and come back. Okay, there's been some horror stories of that happening, so we want to try to limit that, or actually eliminate that safety issue. So make sure they're using the guide fin on their truck. Also, a couple other reasons for that is it helps center the nozzle and the line, so it cleans the line better, and also pulls that nozzle and the end of that hose up off the floor of that pipe, so we don't get as much wear on those components. Okay. And there are different other nozzles too, just to throw at you guys. There's root cutters. The one on the left here is like a saw. It spins, it's going. The one on the right is chain, so that the chain spins around. Cut the roots. These chains, you can change the length for the different diameters of pipes if you need to. Then there's the big, the milling cutters. Those are out there. That's when the operators get those out when there's some some major blockage going on in those lines. So that's some information that I want you guys to know about nozzles. Any questions with that, guys? Again, just some things that you guys can hopefully keep in mind so you're not going down the wrong diagnostic path with the operators. All right, with that, we will jump right into the rotor hose. We're going to talk about rotor hose. These rotor hose can be repaired. We're going to talk about the repairing of these, some things to look for on the rotor hose. Again, I know we got a couple of dealers here, so I'm pretty sure all of our dealers fix their rotor hose. But if you don't, we're going to go through this. We're going to show you how to repair a hose. Maybe everyone else might decide, yeah, I can do that. It's really pretty simple. Hopefully your rotor hose doesn't look like that picture there. Hopefully your operator takes better care of that. But the rotor hose, we call that the most dangerous tool on the truck. The operator standing right there at the hose reel. We don't take good care of that rotor hose, it's going to burst. I've had stories of the hose bursting, hitting the operator, knocking them out in traffic, things like that. So we want to keep this rotor hose in good shape. Okay, the operator should be wrapping this hose up when they're paying it back onto the hose reel. They should be wrapping it up nice and neat and orderly, and then keep it from being tore up. 3 layers of this, the hose, the inner core, thermoplastic inner core, that's what the water runs through. Textile reinforcement, that's very important. That determines how much pressure this hose can handle. If you start compromising that textile reinforcement, instead of holding 2,500 psi, depending on how bad you've tore that up, it might blow at 1,000 psi or 500 psi. So you make sure whenever your hose, if the operator's destroying this hose, it starts getting into this textile reinforcement, you need to fix that section of the hose. Then there's the outer cover. That kind of holds everything together. That's the section we need, or we see. The hoses, there's all kinds of different hoses, so they're not all the same. So if you've got a roll of hose in your warehouse, you want to take 10 feet off that hose and put it on the hose on your truck and your fleet. You want to add that. Make sure it's the same. Okay, make sure it's the same pressure, same manufacturer. Because like you see on there's all kinds of different things to look at: operating pressure, bend radius, inside diameter, outer cover thickness, all that. But we're going to talk about colors. Okay, colors are very important when you talk about rotor hose. The outer color is PSI rating. Okay, so again, if you're replacing, putting a chunk of hose on your rider hose on your hose reel, make sure the outer color is the same. And then the inner color is the manufacturer. Very important. Okay, when you're fixing a hose, make sure the inner color matches everything. All right, the outer color, yellow is 2,000, orange is 2,500. That's what we have on most of our trucks. Blue is 3,000. I believe that's what Matt has on that truck down in the show bay. And then green is 4,000 psi. Some things to look for with the hose: if it's burst, water's coming out there, fix that. Okay, that's an area where you need to get fixed. That you can, depending on where it's at, if it's 20 feet in, you might just cut the section out that where it's burst and just splice it. If it's near the end, what this picture looks like, just cut the end off there and then put a new hose end on it. Blisters or bubbles, it's about ready to burst. Time to fix that section. Cover damage, like I said, you damaged that cover. Now you're into that textile reinforcement. You've compromised that hose. Instead of it holding 2,500 psi, now it's going to burst at 1,000 or who knows what. So you start getting into the textile reinforcement, fix that section of the hose. Kinking or collapsing, I'm going to get my pen out here. Kinking or collapsing, what you could have is, if you kink that, you could have a pinhole here and or here. The water might come out right there, okay, or it might travel between the layers and it comes out right here. Okay, so if you see that kinking or collapsing, try to fix that. If you've got water coming out there, it's time to fix that. A couple notes on that. You see the water coming out here, you haven't noticed where it kinks or collapsed. Maybe you don't have a visual sign of that, who knows? But you see the water coming out here, let's fix that. You cut the end of that hose off. Before you go putting a new end on, take a paper towel, dab the end of that. Make sure your paper towel's dry. If it's wet, there's water traveling between the layers. Go up a little further, cut that. Take your paper towel, make sure it's dry. If it's wet, go up a little further. Keep going until that paper towel is dry. Okay. Once that paper towel is dry, then you can put a new end on that part. All right. Fixing the hose. Really pretty simple. We're going to go through, I'm going to walk you through this, and then we're going to go down to Matt. I believe, yeah, Matt's down there. Matt's actually going to walk us through fixing the hose down there also. So, the main, outer color, like I said, you want to keep that the same. You want to keep pressure rating the same. So if you're splicing on a hose. The inner color, you want to pay very close attention to the inner color. Most of what we use here is yellow. Here you can see the fittings are marked. You can see the one with the hose has got a green. The next one over to the left is blue. There's red and a couple other blue ones. So this one green, will it go with this orange hose? Well, if the inner color of that orange hose is green, yeah, that fitting is a good match. Okay, so the fitting, the inner color of the hose has to match. Also, the dies have to match. Okay, either the whole face is going to be the color, or it might just be a dot or two. Okay, so make sure all the colors match. Okay, so like I said, most of what we use is yellow. So the inner color of the hose is yellow, the fittings yellow, and the dies are yellow. Okay, this is a good picture for me to talk about this. The fitting here on the right, that is the pusher plate. That's what you will use if you're putting a new end on the hose, like this fitting here. So this threaded part will go into the pusher die here, and it will not let the rest of that fitting slide into there. The other die here, it's beveled. So when you start crimping that, that die will slide up the fitting and crimp that. If you're using a splice, so if you've got a bad section 50 feet in, you don't want to lose that whole 50 feet. You just cut out that damaged section and use 2 of these dies here, like this on the left, and then you'll use that for a splice. Okay, fixing the hose. First thing you want to do is cut out the bad section. We ask when we've had classes here in person, we'd ask what the guys that do repair the hoses, what do you cut them with? Just out of curiosity, we have all kinds of things, but hacksaw was a big thing. But Matt and I figured out we can use these PVC cutters. We got these at Amazon, pretty cheap. These are the ratcheting ones, nice and easy, cuts nice and straight. But whatever you're using, make sure it's cut straight, the end of that, so we're not having a problem down the road. Lay the fitting next to the hose that we're putting on. Mark it so you know that when you slide that fitting on the hose, it's on there all the way. Then at the tool, the die, put a little lube on there so it slides good up the fitting. And then the pusher plate, like I said, if you're putting the hose end on it, use that pusher plate. Put the threaded end on there so it doesn't slide through the pusher plate. Put the die in there. Snug up the bolts to hold the dies in place. Actuate that jack till the fittings touch. No reason to go any further. It won't go any further. That should give you, as long as all the colors matched, the hose, the fitting, the dies, should give you a good crimp. So the crimp here on the left, that's a good crimp. You can barely see the teeth there. You got a good bubble. The one on the right, bad fitting, not good. That was done here locally. We had a city up north, I think it was, did this crimp. They didn't think it looked right, so they made the right call, really, I guess. They called me up and said, hey, can you look at this? Yeah, sure, bring the truckers by. They showed me that, and it doesn't have a good bubble. Teeth are too shown too prominent there. Basically, what we did, the hose is yellow, the fitting's yellow, but the dies they used were green, so we got the wrong crimp on that. So got a good crimp. Before you send that back out with the operator, run that truck, run the water full flow and full pressure for 10 minutes. If that splice, that new end holds up, full flow, full pressure for 10 minutes, there you go, Mr. Operator. You're back in business. You can use a canister, this test canister here. There's a part number if you want to use that. You have to put your nozzle in there. Again, make sure you get a good nozzle on there that's going to give you the proper flow and pressure. And then hook your rider hose on to the fitting there. Now you can run the water. Just put that out in the parking lot or something, so if something does burst, it's not going to destroy something. So run this out in your parking lot and run the water through there. Make sure everything holds together. All right. With that, I think Matt's ready. Let me stop sharing here, and I'll hand this off to Matt, and he's going to walk us through fixing the hose down there.
That should work. Give it a try. All right. Start off with the mend goes in the middle. Okay. So this is, for whatever reason, we decided that we were going to cut it in the middle of the hose, 100, 300, whatever feet in. You're not just going to throw the rest of it away. Or maybe we're adding on 200 feet of good hose because the first 50 feet is horrible or whatever. Okay. So that's a mend. Okay. That's putting the hose, a splice in the middle. That's what we're going to call the mend. So let's go ahead and take that apart. Show you guys what the inside of one looks like if you've never seen one. So you can see that there's ribs on the outside. Let's see, on the inside of the outside, and then the outside of the inside. I don't know why we do this to ourselves. Like, my goodness, insides and outsides of everything. All right. There's yellow on the fitting. It's a yellow hose on the inside. And then as long as I use both sets of yellow dyes over there, then I have all yellow, all the same manufacturer. That's exactly what we want. Do not mix and match that. Right. I've marked my hose to my fitting, so that basically just shows me an insertion depth, basically to make sure that my hose is all the way into the fitting. This just keeps me honest for when I'm wrestling that hose, one end on the truck, the other end, I don't know, stretched out across the parking lot or whatever. That way, when I push everything together and then I set it in the machine and I make sure it's together and then I operate the machine and the two dies, one slides up and one slides down. I'm just trying to hold this at the same angle as the machine. So the dies slide up and the dies slide down, and then it actually crimps this fitting. Right? So this is what it looks like. You can see the teeth through the outside of the fitting. You can see this little bit of a bubble. We can see that it's yellow. We can see that the hose was yellow. That's what we call a good mend, okay? You can still see the insertion marks. So the hose was fully inserted. It stayed fully inserted the whole time. Also a very good thing to do. And this is what a not so good mend looks like. So the what happened here is the die slid all the way up and past. And so there's just a very little bit of compression. You can see this is not very, very squished at all. It's not compressed very much. There's no bubble here, so that shows you that this has not been compressed. And then this side was extremely compressed right here, and then nothing up here. So very, very bad crimp. This would not hold very long at all. So I would not want to test this one. I would want to knock off and redo it and hopefully do it differently so I don't have the same outcome. Okay, that was a mend. What we're going to do is we're going to put a new hose end on another chunk of hose. So, all right, let me show you this first and then get this out of my way. This is that key pull that we were talking about. So you can see in there, you can actually see some of the orange in there. So that's a witness. So you can witness that the hose is fully inserted into the fitting. Okay, that's a really nice fitting. Those things are, I would probably expect on the premium end of things. The last time they sent us fittings, they did not send us those. They sent us just regular ones. So we're just going to do a regular one. Yeah, this hose has a really bad leak. So we're going to replace it with another hose end because that'll fix everything. So what we have is, like Jerry said, just I don't even know the brand of it, and it doesn't really matter. It has to be bigger than 1.25 inch hose for us, just for it to work, because otherwise they wouldn't fit inside here. So that's PVC ratcheting. Awesome. They work great. So as long as, even with these super cheap ones, you just have to watch that the blade actually goes straight across. But what I found the last couple of times I used this set is it started to go crooked on me. But otherwise, I didn't even look up if you guys could actually see me doing that or not. But that was really easy. I'm sure you didn't see me wince or cry at all. It's a nice straight cut. It's clean. There's no shrapnel, no jagged edges. That's a really nice cut. That's super easy to work with. Like Jerry said, we usually ask how people do it, and we get all sorts of different answers. That is by far the easiest way I have found or been suggested or tried or whatever you want to say. So I'm going to throw that away. I'm going to replace this now. All right. I do not have any sort of witness mark on here, so I'm going to have to mark it. So in order to mark it, all I'm going to do is I'm going to hold my fitting up to the end of the hose. I'm going to, okay, that's about how far the hose will go in, and I'm just going to give it a mark across here. I just want a nice mark that's not going to go anywhere. I want to make sure that when I get done with this, that it is still fully inserted. If you don't mark it at all, you have no idea if it's all orange, how far it is. Did it stay in? That's what we need to check on. So sometimes, all right, this one's a nice tight fit. Some of these sections of hose that we have that were given to us by Piranha, as we do about 90% of our hoses, Piranha hose, they just lopped us off like 4-foot sections, and we have a whole pile of them over there. Some of these fit real tight, which works really great for training, because then I go get that highly calibrated piece of 2x4, and I hand you that, and I hand you these 2 pieces of equipment. So the hose end is really tight, and you're going to push on it, and you're probably going to get it about halfway on. And then you're going to look at me, and I'm going to hand you the 2x4, and then you're going to take the 2x4, and you're just going to beat this thing on there. Let me make your life a little easier. If you guys may have noticed in the background over here, I have Gojo. So there's no Pullness in there, so there's nothing like that. It's soap. It's just hand soap. So how many of you guys have ever installed or done something that says to use liquid soap, dish soap or something to assemble something? We don't want to use any sort of an oil. So no oil-based or petroleum-based products. So just a little tiny bit of soap on here, because it's going to dry, won't leave you a residue or of any sort. And this thing just slides right on. So little handy bit of information. Plus you can use soap to wash your hands on the truck when you're out running it, right? So fully inserted all the way up to the mark. Okay. And because I am going to do a hose end, the pusher plate is at the top. So what it'll do is it'll slide all the way up in here, and it will not go any farther. Okay. It's all the way inserted. It won't go any further in, because I'm going to try to make this a little easier. I'm going to use a set of dies. Okay. Put the back die in. One thing that we like to do is put a little bit of lube in here, just so that it gives the fitting a little bit of help sliding through. Nothing worse than putting a dry fitting in. Hint, wink, wink. Everybody laugh. All right. Push it all the way up into the pusher plate. Put the die into the machine. Okay. All right, make sure that it's all the way pushed up. I put my seam perpendicular to where my the separation of my machine is. I'm going to go ahead and tighten up this bolt. And you'll notice I don't have to tighten it very tight at all. So basically, snug. Put the kickstand in. Go ahead and tighten up the machine. Everybody's operated a bottle jack at some point or another in their life. So this is the only point of contention, is right here. You just want to make sure that the fitting goes into the die real nice and straight. Make sure that it doesn't catch on anything anywhere. And there we go. It went in real nice, and it just set the die, and there's the resistance. So everything looks good. So I'm going to go ahead and pump it up. As you can see, the die just slides right up that fitting, compressing it the whole way up. And we'll stop when the machine stops. Ready? Oh, a little bit more in there. There it is, right there. All it is, that's all the way. All right, it's going to be stuck in the machine. There's nothing done wrong there. Timeout. Want to know what's so hard? Oh man, you think I'd done this once in my life? Oh, let's take that bolt loose that I told you about. Oh. All right, sorry about that. that's really good. Yeah, believe me when I tell you what to do, right? There we go. Works a lot better when you loosen up the retention device. All right, let me get you right up here. Clean off all the soap. So you can see the fitting, nice and compressed. Got all the teeth, got the insertion mark. Got the bubble, yellow, yellow, all is well. Now we're going to take this. This is the test canister that we have. It's basically a giant piece of pipe, I don't know, 4 or 5 inch piece of pipe. Got a fitting welded into it, a pipe in the middle, and then just attached a nozzle. So that nozzle will be equivalent to whatever truck it is I'm testing. If it's an 80 at 2,500 or a 70 at 3,000, whatever, that's the correct nozzle for the truck. 10 minutes, full system flow, full pressure. So basically the capacity of oil, or excuse me, water on the truck, just test it, set it off to the side just in case something comes apart. You definitely don't want to be catching this hose. But I would much rather it come apart outside of the sewer or manhole or line or whatever it's being run down. Some of these high efficiency nozzles are not cheap. So telling your boss that you just lost his brand new nozzle down in the end of a pipe, probably not going to go over real well. So definitely don't pull that one off. Also, we don't want anybody to get hurt. So definitely don't want the hose coming after you or the nozzle. Because everybody loves carnage, thought everybody would enjoy a fitting that did not go so well. So this got caught up in the die, or it was a completely wrong die. Not exactly sure, but this could have been avoided much sooner than all the way smashed in there. So if anybody wants to test this, I'll let you. Just got to come get it. Just trying to have fun. All right. The last thing I wanted to show you guys is not, oh, geez. I somehow loosened that up. That was not what I meant to do. This truck has blue hose on it. Blue hose indicates what? Anybody? Everybody? All at once? Pressure.
PSI.
Yep, there you go. There it is. So this truck here, 70 gallons at 3,000 PSI. That's what this truck's rated at. There should be a decal on the front hose. It'll have on here what it is. And just in case anybody wanted to see another QR code, there's a location on the front hose reel as well. So, all right, guys, that's what I had to show you for a hose repair. Showed you the truck. Not always do we actually get a different color hose. But yeah, we have one today, so I thought I'd show it to you guys. With that, I'll let Jerry continue. Jerry, you're not unmuted. Can't hear you.
Yep, sorry. There we go. Thanks, Matt. Yeah. We got some a meeting going in the training room next to us. They're kind of noisy, so I didn't want to be interrupting anybody. So if this is too much noise, if there's too much noise, let me know, and I'll say something to them. But that's why I muted myself. But anyway, the last thing I wanted to throw at you guys with this is if you cut off a chunk of hose or add a chunk of hose, you want to change the hose length value and the AccuCounter counter on the screens. Okay, we'll show you where to do that when we get to the screens tomorrow. But remember, if you do that, cut some off, add some to it, change that value just to keep that footage counter accurate. All right. With that, any questions on that before we move on to the next subject here? Yeah, I saw a couple shaking their head no, so we'll go on to the next subject here, which is winterization. There we go. All right, winterization. Basically, winterization, I think I said this yesterday. If your truck is going to be in freezing weather, you do not want to leave water on it. You want to get the water out. If you're, especially if you're 0 degrees, you do not want any kind of water on there. But when the water freezes, it breaks things on these trucks. There's some pictures of the router pump. The water cylinder's busted because they didn't drain the water out of this. Water froze, and it you see what it does there. It's going to break valves, fittings, all kinds of things on these trucks. So if the truck is going to be in freezing weather, get the water out of it. Bottom line, whatever it takes to get the water out of the water systems on these trucks, get the water out. You do not want things freezing. Okay. There is a decal on the truck. Right here, it gives you, on the left, it gives you steps on just draining the water. You know, open up the valves and stuff to get just to let water drain off. If you've got the air purge system on your truck, the top right of that decal walks you through the air purge option. We're going to go through this real quick here, and then we're going to go down to Matt. He's going to show us a little bit on the truck also. But drain the water systems. You know, first thing everyone thinks of is the water tanks. Yeah, there's expansion plugs. So take the expansion plugs out of the water tanks and let them drain. There's remove the Y strainers, open the caps up, you know, take the clamps off, take the caps off, take the screens out, put all that stuff in the toolbox so you can put it all back together the next morning. The rudder pump inlet valve, make sure that is open. That way you can make sure this, if you have the center water tank underneath the debris body, you can make sure that gets drained that way. I'm going to go through using the air purge option. So if you have this on your truck, I'm going to walk you through using this option to get the water off the truck. If you do not have this, you can use the rudder pump. You can, you know, with all the water drained out of the water tanks, you've got the white strainers out, you've got the rudder pump inlet valve open. So you have no water, you can run this rudder pump. Okay, our spec is a half hour. I've had engineers tell me that they've run them a lot longer than that, but you can run these rudder pumps dry because it's so slow, and the inside the cylinders so smooth, it doesn't build up a lot of heat, doesn't build up heat to start melting the seals or anything. So you can use, if you don't have the air purge option on your truck, you can run the rudder pump. It'll act as an air pump and use that air to put out the water. But I'm going to go through the operation of the air purge here. Air purge is using the chassis engine air, that air on the chassis to push the water out of the system, the water systems. So you want the truck running. Put the truck in jet mode because we're going to be operating some things. We're going to actually stroke that rudder pump back and forth a few times, and we're going to rotate that hose reel. So the engine you want running because we're going to use chassis air, and then put it in road and not road, in jet mode because we're going to be using some of the hydraulics. Right. So we're going to start with pushing the water out of the rudder hose. So make sure that hose reel main water valve is open. So flip it all the way up. Then at the air purge, we've got the air here on the left is the air purge system. Turn that on and off. In the center, there's an air gauge. There is back behind the scenes is an air tank, and this gauge tells you how much air pressure is in that tank. And then the valve here on the right is a fill air reservoir on and off. That sends air to that tank. All right, so going through that, make sure the air purge system valve is off or closed. And then open the fill air reservoir valve. Now we're going to be sending air to the air tank, the air reservoir. That gauge is going to tell us how much air is in there. Fill the tank to approximately 100 psi. Some guys 90, some go 110. If you want to wait long enough, 120. So I just picked 100 psi. So fill that till it says 100 psi. Then the fill reservoir, turn that off. Now we're not sending any more air to that tank. Then open up that air purge system. Okay, earlier we opened up the valve, flip that switch for the main water valve, so it's going to be sending the air to the rudder hose now. All the other valves are closed, for the body washout, fan washout, hose reel, all those things, all those are closed. So once we turn this valve on, now all the air is going to be pushing the water out the rotor hose. Okay, it's going to start pushing the water out. You get a big stream of water come out the end of the rotor hose. So once that air in that reservoir gets down to 15, 20 psi, and it's going to happen, close that air purge system valve and open the fill air reservoir to fill that tank back up with water. Okay. Once it gets to 100 psi, close the fill air reservoir valve and open up the air purge system, and it's going to start that process again. It's going to start pushing the water out again. Okay, you're gonna have to do this a few cycles, 3, 4, 5. If you have a lot of rotor hose, it's going to take more. If you have 400 feet of rotor hose, it won't take as much, but it's going to take a few cycles all this to get all the water out the rotor hose. The other thing you'll find is as we're getting less and less water left in the rotor hose, this pressure is going to drop a lot faster. Okay, so just so you know what to expect. So we've gone through this cycle a few times now. We're getting very little water out of the end of the rotor hose. Okay, make sure that take the nozzle off the end of the rotor hose, zip tie the end of that rotor hose to the adjacent wrap of the rotor hose, because do this before we even get started. That way, that hose end isn't going to be flopping around from the pressure. But now we're at the point where there's very little water coming out of this. Rotate that hose reel clockwise. If you're standing there looking at the front of the truck, standing there in the front of the truck looking at the hose reel, rotate that clockwise. We do that because that air is not going to get out 100% of that water. The water is going to accumulate on the lower wraps of this hose. So gravity just pulls that water down and it settles there at the bottom. So if you rotate this, every time you rotate this around, that hose reel, that hose end gets around to the bottom, you'll get a squirt of water coming out. Basically what we're doing is we're unscrewing the water that's left at the bottom of the wraps. We're unscrewing that water out of that rotor hose. So again, every time that hose end comes around, gets around to the bottom, you're going to see a squirt of water coming out. Depending on how many wraps, how many layers, is going to be determined by how many rotations you're going to have to do. 600 feet, I've counted this a couple times, and it was around 75 rotations. So this is the biggest time consuming of winterizing, is turning that hose reel. So, which really isn't that hard. Once we get all the water out of the rotor hose, now we can come back here to the water control panel, and we can do each of the other water circuits one at a time. So make sure you close the hose reel main water valve and open up each of these one at a time, and go through the cycle of the air purge there. So close the air purge system, open up the fill reservoir, let the gauge charge up to 100 psi, close the fill air reservoir, open up the air purge, and let's say we're doing the body washout. You open that up, make sure that's open, and then when you open up the air purge, it's going to send the air through the body washout system, and it's going to push the water out the body washout nozzle in the debris body. With that said, you'll want to have that rear door open and the body up, so the water is going to drain out of that debris body. Same thing. Are off. Make sure all the other valves remain open. All the circuits, make sure those valves are open. Make sure the switches are both open. And also what you'll see is on the decals, wherever it says drain here, wherever it says drain here, there's going to be a drain plug, a quick connect, something for you to remove there to help drain any water out. Okay, there's going to be a few other drain plugs. Like the handgun, make sure there's no water sitting in there. Again, if there's water sitting inside that, it freezes, it expands, you're destroying that handgun. There is a drain plug on the bottom of that accumulator. If you remember me talking about this earlier, that hose, it's a straight shot for that high pressure manifold on the rotor pump. You don't have to, normally you don't have to take the drain plug out. If you do, make sure this valve is open. If this valve is closed, you run that risk of this being charged with high pressure water. You take this drain plug out and it's coming at you like a bullet. So be very aware of that. But as long as this hose is straight shot down to that manifold, just make sure this valve is open. No need to take that drain plug out. There is the lowest point in the water system on these trucks is right behind the front bumper on the driver's side. You can see the sequence of pictures here. Gives you a good indication where that's at. There's a little block there. Decal there that says drain here. Take that drain plug. Like I said, that's the lowest point of the water system on the truck. Take that out so you can drain that low point there on the water system. That high pressure manifold, that block there, there's a drain plug there. Take that out. And now all the water that's in these hoses in the block will drain out. Like here, right there's that, if you're following my red dot, that's the accumulator. You can see that line's a straight shot down. Then also make sure the pump drains are open. Now, guys, let me take care of this. All right. So I'm sure the open actually at this point. There. And then also do not forget the heat exchangers. Those are really susceptible to freezing. They freeze, those tubes collapse and break, and now you're going to get water and oil mixing. So make sure you open up those drains for the heat exchangers. Very important there. And then all this stuff that the caps, the plugs, the expansion plugs, the Y strainers, the caps, all that, put all that together in the same toolbox. So it's all together. So in the next morning you can get back to the truck and put it all back together, get it ready to go for the operation the next day. So with that, I'm going to hand that back to Matt. He stop sharing here. Hand this off to Matt, and if I gave him enough time to be ready here, he's going to walk us through this also, so you can see it on the truck.
All right. First thing I want to start off with is letting you guys know I'm in jet mode because I'm going to have to run the hydraulics. Panel is in charge right now, but we're about to fix that. I've already turned my wireless belly pack on, and great reflections today. Yeah, you can see there's some words on there. Press the remote button, it switches to wireless. We're going to go back over a lot of that when we talk about wireless, but just so that you guys know, I'm going to turn wireless on to do this, just so I can do everything I want to while I'm out and about. All right, so initially what I'm going to do while we're draining the tanks is I'm going to turn my rotor pump on. I'm going to open up my drain valves. Right, there we go. Low water. I'm going to silence it. The alarm's going off because there is no water in this truck. So I'm just gonna set this right here. I'm gonna walk around. Take this drain plug out right here. Oh, look at the water flying everywhere. And the last one. Why does this thing keep popping up? There's something about sending feedback. Keeps popping up on the screen. It takes over the whole screen. I can't see anything. All right. Take a drain plug out of the. Look, it even turned the whole picture. Okay, I don't know what happened there. Let me spin you guys. Okay. All right. I took that drain plug out. Hopefully it is all caught back up. That was weird. Go around this way. Drain plugs are still in all the drains other than for the tank. Okay. Gonna put you guys at a weird angle. So I'm letting the rotor pump cycle back and forth with the plugs open. Oh, let me open both heat exchangers. I have two heat exchangers. One is for, and the other is for. All right, hopefully the answers are, one is for the hydraulic oil cooler, and hopefully the other answer is for the engine cooling. Okay, I purposely got out the hydrant wrench. I want you guys to see, this is the one that usually gives everybody a hard time, because of course gravity is fighting you. I'll take our, hold on, the alarm's going off again. There we go. And because it has the Pentastar on it, like I can grab onto it and I can spin it and I can actually take it off. Sometimes it's actually pretty tight. Supposedly it's supposed to fit. I've never tried this. Hey Gary, if it fits, this one needs to be deburred for it to fit. We'll have to be careful about saying that to everybody. That doesn't fit on there.
Yeah, I can't say I've tried it.
Yeah, I've never tried it. I would say maybe if the edges were cleaned up, it might, because it kind of starts on there, but. Okay. That whole, the hydrant wrench works. Doesn't work. I can tell you now that there's something to grab onto, though. It works much better than it ever used to. So there's to the basket. There's to the housing. You guys that have older trucks that don't have this lid on them, you can buy this lid, and then it will work just like this one does. Pretty slick, right? Just looking on the inside to see what kind of debris is in there. There better not be anything, because they're not supposed to even use these when they test it. So put all my stuff back away with the hydrant wrench that does not work. At least that one doesn't. Close that so I don't smash my head when I go underneath this. All right, so Jerry told us I could. So I'm going to turn my water supply off. And if it was super stuck, like nobody checked it, I could actually turn the supply on and water would come flying out. It would push all this stuff out. But I knew there was no water in there, so pretty confident I wasn't going to get stuck. All right. We're going to check our Y strainer every day because Jerry told us to. I'm going to turn this alarm back off. I'm actually going to go ahead and turn my rotor pump back off. I'm going to close the valves, and then we're going to go out front, and I'm going to show you what happens up front. Oh, after I can show you this. Sorry, guys. My brain is still that I already showed you this, and I haven't. So this one here is the supply valve. So there's an air cylinder back there. The old Plus used to have a big old gate valve right on the front here, and it would be somewhere between the Y strainer and right on the back corner usually. This one, now we have an air actuated valve, so you don't have to climb underneath there anymore. You can turn your water supply on and off. So the excuse of I have water on my truck, I can't check my Y strainer, that doesn't work. We put a valve in here to isolate your supply. You can still check your Y strainer. All right. Leave that open because that's fine. This is the water hose on and off valve. So the old trucks used to have a big ball valve on the front hose reel. Now what we have is the control air switch right here. That controls that. I don't know if I'm pointing to the right thing for you guys, but that big blue valve back there with the red knob, you can see the white indicator. That's what this air switch is controlling. So I'm going to move it up to the middle position. If you guys notice, nothing happened with that valve. The middle position is what we'll call neutral, okay? Neutral. If I flip this valve all the way up, you watch the indicator go in line. So now we just open the supply to the front water hose. If I put it back to neutral, you'll notice nothing changed there. I'm going to bump it. So just like Jerry told us, I can't see it and get out of your way at the same time. So if I go too far, there we go. We're going to stop right there. I'm in the neutral position. That's the only way I can stay in between completely open and completely closed, is be in that neutral position. Jerry told us a couple different reasons as to why we would do that. We have a small hydraulic or small water circuits right here. These water circuits, if we were using these, but we still wanted to keep water flowing throughout the whole system, you're only going to get roughly about 20 to 30 gallons out of these small circuits, no matter how high you turn up your water pump. So multi-flow down only as high as you need. The rest of it's just going over the relief anyways. You're building heat. Well, if you're going to build heat, you may as well hook up your recirculator if you have one and start closing that valve off. And then you can recirculate some water while you're doing whatever you're going to do with these two high pressure circuits right here. And then you can at least be recirculating water. If you're moving water through your heat exchangers, you're actually cooling your hydraulic oil and you're also cooling your engine coolant. So that's how that's going to work. If you don't move water, you're not cooling anything, okay? Mental note, everybody's good or all on the same page. If we're, let's see, yeah, using that, we talked about that. What was the other one? I really don't have anything else. That was really the major two I could put down. All right. Yep,
Yeah,
that's
I
it.
think that was
Open
it.
or close. Okay. You never know. Every once in a while, I squeak one in there and I forget about it. So
Yeah.
consistency. All right, we're gonna leave that open. Actually, you know what? Let's start with. Yeah, we're gonna leave that open. We're gonna pump air from our rotor pump all the way out our rotor hose. Okay, so we're gonna leave that open. Leave our supply open, even though our Y strainer's wide open right there. I don't know what's about to happen here, so we're gonna find out. I'm gonna turn the rotor pump back on, and we'll see if any air pumping does anything up front here. So I'm just gonna unscrew my hose, see what it does. I got a little bit of water to come out of there. So basically we're taking the low spots, moving it to the high spot, and the water is just flowing right through that hose. So almost like a siphon. If it was full, it would start a siphon. You guys can see the auto wind guide is about to come back around. So the wind guide moves at the same speed every single time, back and forth. It matches somewhere in the middle. So it's a little slow when you're on the outside wraps, and it's a little fast when you're on the inside wraps. Or the other way. Is the cup half full or half empty? All right, you can see I'm getting some water come out. All right. I'm going to stop. I'm going to turn the rotor pump back off. So because this truck wasn't completely full of water, you guys didn't get to see just how much that rotor pump will do. But I'm going to show you guys the difference. So technically right now, what we could do is we could shut off this and open up our two valves. We could even open up our body washout and turn our rotor pump back on. So now we're running our rotor pump again, and we're basically pumping air through the smaller circuit. So if we had water in there, the air would be pushing the water out And like the high pressure hose reel over here, you can't see. You can see the fitting for it. That's recirculating back to the tank if it has the hose on it. That's going back to the tank. This high pressure coupling right here, that's where it's going, is right here. I can hear the air coming out. And you guys are probably going to wonder why that's on there, and the answer will come in a moment. We are also pumping water into the body, or air into the body right now. All right, go ahead and open that back up. Close these two, and we're going to turn our rotor pump back off. If we do not have air purge, that's almost all we can do, okay? We have we've used the rotor pump as an air pump, and we've cycled it back and forth. We've put, it measures on the pressure gauge, which is right there. Actually, let me show you guys. Set up right there. Oh, that bracket is right in front of it. It's still there. There it is. That red electrical line right there, that's the water pressure gauge. That's a sensor. It's right here at the rotor pump. All right. It actually measures about 30 psi of air pressure when the system is full of water. It'll measure about 30 psi. So, little mental note. All right, like I said, that's about all you can do if you do not have air purge. Unless, because we're mechanics and we figure out ways to do things, there happens to be a set of air tanks right there. This happens to be an air fitting right here. What's to say I were to think of a way to somehow get an air hose to go from that air tank, maybe to right here, and turn that valve on? Maybe I could air purge my truck. Let's see, this is for this valve. I just turned my valve on. I now connected the output of this valve to the supply, so it went right back to the rotor pump. Well, if that's the case, what if I were to, I don't know, maybe get some shop air, hook it up, and turn that on? Huh. I wonder what's happening right now. Well, I don't know if you guys will be able to see it. It's going to be kind of hard for you guys. But right there, coming out the end of the rotor hose is dribbles of water. It's spraying water out the rotor hose. You can see the splashing on the ground. I'm air purging with shop air. Run the hose reel, unwind it again and again and again. Do that for as long as it takes to give you confidence that there is no water out there in that rotor hose. Okay. Now, we have a truck with air purge. Let's use, by the way, if you guys have never seen one of these fittings, might be right here as a dummy plug, in case anybody was trying to idea. Okay. I'm going to leave it alone before I get myself into trouble. All right. So I'm going to fill my air reservoir. I'm going to turn it on. I'm going to build air pressure. I did this before. Let's see. Let's do the small ones first. Let's go ahead and redo it this way. I'm going to take my plug off. I'm going to open my valve. Jerry told me to open a valve every time. I'm going to turn my air pressure on. Yep. Got a little bit of water coming out. Hold on a second. So I'm using chassis air pressure to air purge my truck. What happens if my air tanks aren't dry? What if I live down south where it's super humid all the time? If you try to put wet air into your water system, you're not air purging correctly. So let's drain our air tanks because we are using chassis air. There is a reservoir. I don't even know where this one is. Usually it's buried right behind here. I can't see it. Somewhere in the subframe. I'm going to leave that one alone. The second time now, I couldn't find it when I needed to. All right. I'm going to close the valve. I'm going to open our rotor hose. Turn it on. You guys notice how fast this gauge is dropping? That's a really good sign that there's not much water in that system. All right. Let's combine those two actions next time. So I'm going to go ahead and run my rotor hose. So I'm now air purging while I'm cycling, unwinding my rotor hose. Round and round and round and round and round. I don't see it spraying much water, and we're just about out of air. We'll close it. We'll keep unwinding. I'll repeat this process again and again and again and again. It takes as long as you want it to take. Okay. Let's face it. If this truck is going to sit outside tonight, it's going to get 20 degrees, and I don't want to break anything. I'm going to ensure I got as much water out of that pump and these valves as I possibly can. Once I feel comfortable, I'm going to do it one more time just to make sure. If you guys are extremely paranoid, maybe you can figure out a way to get some antifreeze, some RV antifreeze into the system. Can at least protect your pump. Maybe you could even start purging, pushing some water into the smaller valves. If you wanted to fill the system with RV, I guess you could. Gonna take a little bit of being creative, but I bet you guys could figure it out. Next thing I might do is with that shop air. If I have shop air, I'm gonna do this until I get tired of doing it. Shop air, almost unending supply of air. Do it as many times as I need until I feel comfortable. The very last thing I can tell you guys about winterizing is before we put any sort of water control device on those two circuits or onto my rotor hose, I want to watch water come out just in case I have icicles or ice chunks or projectiles of ice, whatever you want to call it. I want to make sure I'm spitting out clean water. I want to use the water to finish thawing my valves, per se. This is going to be the very first spot that freezes, is right here, all these metal valves, okay? The next will be somewhere in the small little, the little lines along the way. And the next will have ice chunks in your rotor hose. So always, before you put the nozzle on and start running it, make sure that we spit water out. Make sure that we got a good clean flow of water. The last thing you want to do is put an ice restriction in your nozzle or handgun or lance or whatever else you guys have going on. That right there is the check valve for the air purge. So we're pushing air through there. It's not able to push water back out. Okay. There's your check valve. Think about that when we're doing this. That's what this truck has. Gary told us about the accumulator and the valves and making sure that they're all downhill. It does drain. If you do close those valves for whatever reason, do not pull those plugs until the valves are open. This plug right here is how we're going to drain all of that right here, where it all runs to this high pressure manifold. This line that goes up to the rotor usually goes up and over the frame and the fender, the frame and up to the front. You can see there's a hose clamp right there, and I believe you guys can kind of make out there's some hoses in it. That's the highest point of the rotor hose going up to the front. So it drains down here, and then it drains down to the right behind the hose reel on the back side. The very last step I have to do in winterizing is take these plugs out behind the drain here. If there was a valve, drain here, drain here, drain here. So this is for this one. Got a drain plug here. There's another drain plug over here on the recirculator line. Right there on the recirculator line. And then the last one to take out, I'll walk you guys around to it. It gets forgotten about all the time. That one right there. So I showed you that high point that was right underneath that toolbox. This is the lowest point on the whole truck. So this point is where all this water will come out. And then from the bottom of the hose reel, this direction. If you guys drive from whatever you're last doing this to from your winterizing, if you drive the truck, I guarantee you're going to have water dripping out of here, even after you winterize it. Never fails. All right. I've touched on everything that I've seen so far. Back to you.
All right. Thanks, Matt. Any questions on that, guys? Really, bottom line, get that water off that truck before it freezes. You don't want the water to freeze and destroy things. With that, we'll move on to the next subject. Let's see, we've got it's 2:25, so we got 35 minutes. I think we can get through this next section here. Next up is we're going to talk about the hose reel. All right. Hose reel. The hose reel, for you guys that don't know this, the hose reel can be extended out about 15 inches from the bumper of the truck, and then you can rotate that about 270 degrees with it extended out from the front bumper. What's that? Okay. All right. Next, we're going to talk about controls, the hose reel controls. There's a control panel here. We're going to go through the controls here fairly quick. Again, you guys are technicians. You have enough common sense to know if it says work light, you know if you push that button, the work light's going to come on. So I'm going to go through this fairly quick. But again, if you need more explanation, if I go too quick or something, just say something, okay? I spend a little more time with this on the operators, but technicians, I want you guys to know where all the controls are. If you don't know how to operate the truck, you can't fix it ultimately, or at least make sure it's fixed. With the controls here, the switch pods and the joysticks, both the joysticks, they are on the CAN bus. Okay, so each of those four components have 4 wires. So 4 wires at the boom joystick, 4 wires to the hose reel joystick, 4 wires to the vacuum control keypads, and then 4 wires to the setup keypads. 4 wires, you got power, you got ground. Since it's on the CAN bus, you got CAN high and CAN low. That's all the wires to all those. So it really cuts down on the wiring on these trucks. It lessens the wiring, I guess. So you push a button, you move a joystick, it sends out a signal on the CAN bus requesting that operation. The other controls that's on the control panel, they are inputs to the ND4 screen, the IntuiTouch screen on the top portion of that control panel. All right, so you push a button, it's an input to that. You move the potentiometer, it's a variable voltage going to that, the input on that ND4 screen. We're going to go through all these controls individually. Some we'll spend a little more time on than others, but we're going to go through the setups buttons first. But before we do that, just a quick note for you guys. We had a company come out and kind of guide us through the setup on this. What we've found is what they've done is group all the controls together. So the first thing we're going to talk about is the setup buttons there. So everything you use to or might use to set up the truck, get it ready for operation, is in that. Right below that, it's set up top to bottom, left to right, basically. But all the jetting controls, you can see right there in that the blue area there for the operation of the rotor pump is right there. Your vacuum controls just to the right of that. Then all your boom controls, and then your hose reel controls. They're all grouped there together. So there's no bouncing around all around the control panel here. So everything's grouped together just to make things more intuitive, a lot easier to operate. So the hose reel controls, the setup control, the keypad buttons here. I'm going to go through this real quick. Again, you guys are technicians. You have some common sense here. But the wireless remote switch, if you want to use the wireless This is how you turn that system on. You want to turn on the belly pack first, and we'll go through the operation, the turning on of the wireless tomorrow morning, I believe it's going to be. But turn on the system is that button there. You got work lights. Okay, there's the boom side work lights, hose reel work lights. If you have all three of those lights, all three of those buttons are going to work. If you only have, let's say, you only have the boom work lights, you don't have the side or the hose reel, those two buttons are still going to be there. They're just not going to do anything. Okay, then bottom left is a hose reel lock switch. You push that button, the locks retract, and now you can pivot that hose reel to line that rotor hose to the manhole better. Okay, you move that hose reel in position, you stop it yourself, hit that button again, the locks extend and lock that hose reel in place. Okay, it doesn't say hose reel break, it says hose reel lock. So don't use that to stop the rotation of that hose reel. You know, don't give it a spin and then hit that to actually stop that movement. You stop it and then hit that switch. If you use that as a brake, you're going to break the switches, or you're going to break the locks. Now you're going to have to take the hose reel apart and replace those parts. And I'll show you where those are here at the end of this PowerPoint. The pinch roller, if you have that option, that's an option. There's a big roller on top of the hose reel. It helps keep the rotor hose wrapped nice and tight on that hose reel. Again, like I said, with the footage counter, if the operator really should be wrapping that hose reel, the rotor hose back on the hose reel nice and neat and orderly. It's going to keep that footage counter accurate. If you don't have the pinch roller option, the button's still going to be there, but it's just not going to do anything. And I told you this extends and retracts out from the front bumper. Those are the two buttons to make that movement. You hold that button, you're going to get the movement. You let go of that button, the movement stops. All right, the e-stop is the next one to the right there of the setup. Switches, the e-stop, I told you guys you need to check that every day. That should be something the operator does as they're going through their morning checklist. Just hit that e-stop real quick, make sure it works. When you hit that e-stop, should turn off all the major components on these trucks. So the PTOs will stop, the chassis engine will go to idle. We do not ever ask the chassis engine to shut off, just to idle. It opens up the vacuum relief and it shifts the automatic transmission to neutral. So basically, when you hit that e-stop, you're losing all your water flow, all your hydraulics, and all your vacuum. Okay, so all the major components that could be causing harm and damage, things that can hurt you, should be disabled. Okay, like I said, the engine will not be shut off. If something, I can't imagine what it is, but if something's happening and there's an emergency, you need that chassis engine off, you're going to have to jump up in the cab and turn the key off. The e-stop, when you hit an e-stop, there's a couple e-stop buttons. There's one on the side there with the body controls. Then there's one on the control panel here. You hit one of those e-stops, all the LEDs in these buttons will go red. Okay, every one of them has a red LED. The red LED will illuminate. That's a good clue that you're in an e-stop. And you'll also get a message on the screen that tells you which e-stop button was pushed in. Okay. Something happens, you hit that e-stop, all the red LEDs glow red, and then you get this message. And again, you're not going to be able to do anything with the truck. You've lost all hydraulics, water, and vacuum. The things that's not going to hurt you, like the work lights, things like that's going to still work. But just the major components that's going to hurt you or cause damage or something will stop. Okay, whatever problem there was is done and over, taken care of. You're ready to go back to work. You release that e-stop button. You're not going to leave the e-stop mode yet. you're going to get this message. All the red LEDs are going to still be illuminated red. Nothing's going to work on the truck yet, but you're going to get this message asking you if you want to return to jet mode, or if you're in combo mode, they'll ask you, do you want to return to combo mode? Okay. With this message, kind of a side note, nowadays everyone has a phone on them. So you tell your operator, if there is a message that comes up on the truck, take a picture of it. You guys as technicians will find a lot of value in that. These messages on these trucks, on the 2100i, a lot of them has some very useful, very good information. If you leave it to the operator's memory of what that message said, you're not going to get good information. Have them take a picture of it. That you see that message and you can read it. Some of these messages, depending on what the message is, why it's there, some of them will actually tell you a circuit that there's a problem on. Is it open circuit? Is shorted? Things like that. So it'll give you a lot of good information. So have them take a picture of that message so you can see it and read the whole thing. This message kind of leads to that. I'm gonna read through this and we're gonna talk about this. So return to jet mode. Okay, that's the question we want to ask. Okay, it says, keep on reading. The e-stop button was deactivated. Okay, great. Yeah, I know. I pulled it out. To return to jet mode, press and hold the top center vacuum keypad button that has the chasing lights. Okay, if you haven't ever hit the e-stop button on this, that probably makes no sense to you whatsoever. Okay, we're going to come back to that. Okay, I'm going to go to this second sentence here, and we'll come back to that first sentence. Okay, so going on, it says to remain in e-stop, close this message, and re-engagement will need to be performed in the cab. Okay, so if you want to remain in e-stop, you can just hit that X. That message goes away. The truck stays in e-stop. So all those LEDs are illuminated. You get no water, you get no hydraulics, you get no vacuum. Okay. Okay, now, for some reason you want to stay there. Okay, you've addressed whatever needs to be addressed next. Okay, now we're ready. According to this message, re-engagement will need to be performed in the cab. What that is you're climbing in the cab, you're shifting that back to road mode and back to jet or combo mode, whichever mode you're wanting. Okay, in this instance is jet mode. Okay, a little trick there to bypass that. Instead of climbing in the cab, hit that e-stop button, still, and now we're back to that previous sentence. It says the jet motion vacuum keypad button that has the chasing lights. So what that is on the vacuum keypad, the center button, the LEDs are just flashing through. Hit that button. You're going to have to hold it a second. Once you do that, it comes out of e-stop. So the chasing lights go away. All the LEDs go away. You're back now. You can operate on everything on the truck. So that's our e-stop operation. And as you can see, it had a lot of good information that gives you a good clue on other messages that you can see. Read this through the whole thing and get that information. The jetting controls, that's next. Our rudder pump switch. Okay, if we want to turn on the rudder pump, we saw Matt do this. But there's a safety in here. We didn't want someone accidentally turning on the rudder pump. Just accidentally hitting that switch and starting that rudder pump. So you have to double bump that. Just tap, tap real quick. You'll get the blue LED illuminated in the switch and the pump working. Okay, now the rudder pump's going. Counterclockwise, less flow, less pressure. Okay. Something operators do, they just turn this up as far as max as it'll go. Do not do that. Turn that clockwise until you've achieved the flow and pressure you're looking for. Stop. No reason to go any further. Okay, mainly, again, these trucks can be used for hydro excavating. You know, these trucks are rated to buy at 80 gallons per minute. Okay, if you got an 80 gallon minute nozzle, if you crank this all the way up, yeah, okay, we're getting 80 gallon minute. If you're hydro excavating, this is where we see this problem more often. Okay, if you're hydro excavating, again, start with low. Those hydro excavation, those nozzles used digging with water, a big nozzle is going to be 12 gallons per minute. Probably you might be closer to 7 to 8 gallon a minute nozzle. Okay, so start with this potentiometer low, turn it up till you get whatever pressure, if it's 2000 psi, whatever pressure you're aiming for, turn that up until you get to that point. Don't go any further. Okay, what operators do, like I said, they just crank this all the way up. They want to get as much work out of this truck as they can get. Well, they turn this all the way up. This system's trying to pump out 80 gallon per minute, but they've got a nozzle on there. They're hydro excavating, and they've got an 8 gallon minute nozzle on the end of that line. There's a lot going over relief now. When things go over relief, we're building up a lot of heat. Now we're overheating the truck, and eventually the truck shuts down because it's too hot. We do have a hydro excavation mode, tomorrow. But I don't care what you're doing. Even if you're jetting a sewer line and you've got a 40 gallon a minute nozzle, don't just crank this up. Crank this up until you achieve the pressure you want or that you're shooting for, and stop. Okay, no reason to go any further. Again, if you're trying to push 80 gallon a minute, you've got a 40 gallon nozzle, it's going over relief. You're building up heat, things. All right, vacuum controls. Let's see, you've got just go over 20 minutes here, less than 20 minutes. Vacuum control, increase, you hit the top of that button, decrease, you hit the bottom. You can tap it, you can hold it, go either way, increase or decrease. A lot of our chassis is CAN communication for the throttle control. On those trucks, you can double bump that. We saw Matt do this yesterday. Double bump that decrease portion of that switch, and the truck will automatically ramp down to idle. Okay. Like I said, most of our trucks will do that. Some of them will not, like the International, I believe, don't. So if your truck doesn't, I wouldn't worry a whole lot about it, but just so you know what you might be seeing on your truck. Our vacuum, again, if you've got front blower controls, you're going to have a button here to turn on and off the blower. And then the vacuum enable disable switch. Every one of our trucks is going to have this vacuum enable disable switch. You hit that button, it opens or closes that butterfly to give us airflow or shuts off the airflow at the debris hose. Okay, this, again, the front blower controls. If you have a blower unit, you got front blower controls, you can turn on and off the blower here. In the cab, you shift the truck into combo mode, and we'll walk through this again tomorrow. Matt did this a little bit yesterday. But shift into combo mode, you get the message on the screen. Combo mode engaged. Okay to exit the cab. Now you can come out, and you can set up the truck, put vacuum tubes on, get the nozzle on the hose reel, whatever you're doing to set up the truck. Now, when you're ready, you can even clean the line, 200 feet, 500 feet, whatever. If you're not ready for vacuum, you don't have to turn it on until you're ready. So now you can hit this button, turn the wheels. You're in the cab, you shift into combo mode, that blower's going. Okay, there is no turn on and off the blower out front. If you have a fan unit, I talked about this a little bit yesterday. In the cab, you shift into combo mode. You get the message saying combo mode engaged, okay to exit the cab. Come out here, you can turn the fan on and off, and then select fan speed, low, mid, or high. The other thing I want you guys to know about, mainly the throttle. This is where we see an issue. If your truck goes into the chassis dealer and they re-flash the control module, there are parameters that we set in those modules on the chassis side, just so that we can control the throttle up and down. Okay, so this throttle increase and decrease button will work. Okay, if they flash that module, those parameters are wiped out. Okay, they're increase the throttle. Those parameters have to be reset. Okay, if the technician is good, he'll take a snapshot of all those parameters and reset those. But just so you guys know about that, that's a phone call service gets a lot. The truck goes to the chassis dealer, they get it back, throttle doesn't work. You have to take that back to the chassis dealer saying, hey, you need to get these parameters reset. They're gonna, at that point, they're gonna say, I don't know what you're talking about. I have no idea what those parameters were. You can call up Vactor. They can get those parameters. Depending on what chassis it is, you might have to give them a little time to get with engineering to get those parameters. And then they'll send those to you so you can get those reset. So same thing with the Allison transmission. There's parameters in there. They reflash that. Those parameters are wiped out. You need to make sure those parameters get back in so we can, for one thing, control the shifting of that transmission when we need to, and so we can control it also. So if it goes into the chassis dealer, comes back, throttle don't work, or you can't shift into different modes, things like that. As soon as you get back from the chassis dealer, very good clue of what's happened. Take back to the chassis dealer, have them reset those parameters. All right, the hose reel controls. There's the joystick. First off, let me do this. See here. I'm gonna get this finished today, but we're gonna try. You can see here there's where it says lift. If you've never used this, just so you know, the joystick in the center. So if you move this lower rim, lift this up, it unlocks that. Now you can move that joystick. Okay, payout direction. That hose reel is going to start moving slow. You move that along a little further along this travel. It'll go faster. You get to the end of its travel, it's going to be going as fast as you've got this potentiometer here set. Okay. If you want that hose reel to go faster, turn this potentiometer clockwise. If it's too fast, you want it to go slower, turn it counterclockwise. Okay. So again, you move that joystick just a little bit. So there's a potentiometer in that joystick. You move it a little bit, that hose reel is going to be slow. Okay. The further you move that joystick along its travel, the faster it's going to go till you get to the end of the travel, and then it's going to be going as fast as you've got this potentiometer set. And the boom joystick, we talked a little bit about this already yesterday. Up, down, left, right. The knob here on the end is twist clockwise and counterclockwise for extend and retract. And then the hose, debris hose up and down for the RDB boom and the 5x5. If you don't have one of those two, you'll have the telescopic boom. The telescopic boom, you will not have the red buttons. It's just going to be a red knob there. I think we can get through this today. We'll see. It'll be close. The hose reel drive motor. Yeah, just so you guys know where this at. Remember this yesterday. We're going to talk about this motor. We're going to talk about this tomorrow. We're going to talk about it yesterday. That's what I said. Just hydraulic motor tomorrow, tomorrow afternoon. But just remember, I try to get a good memory where that's located at. There's a panel that goes over that. So if you want access, but this gives you a good picture where that's located at. But the footage counter, there's a sensor that's where we get the rotation speed and then the footage counter information. Now that's where the sensors are located at that hydraulic motor. This the control panel on that hose reel is you can't adjust that. There's this air switch on the frame of the hose reel. Flip that switch up. Now you can rotate that control panel out. There's it's air. It sends air to this the pintle here. Flip that switch up, and I think it's up anyway. Flip that switch one direction. This pintle will retract. You can swing that out. There's about a dozen little indentations there. Flip that switch up. That pintle extends and will lock that control panel in place. On the back, you can see this gold quick release lever. Flip that up, and now you can actually raise and lower that whole control panel. For someone short, someone tall, if you're standing on a curb or the crown of the road is extreme. So if you need to move that up and down, you have that option. Some people are looking for rear controls on these. There is no control panel that is mounted on the back of this hose reel. But if you want controls on the back, there's this docking station. Turn on the wireless, put the wireless in that docking station, and now you'll have controls on the rear of the hose reel. There's a manual wind guide that comes on the hose reel. As the operator's operating this truck, paying the hose back on the hose reel, he'll use this to wrap that hose orderly and neatly back on the hose reel. If you don't have the manual wind guide, you're going to have the auto wind guide. Matt showed us this. The operation of that is he was turning that hose reel just a little bit ago. That hose goes between the rollers, but the auto wind guide will go up and down this track here as that hose reel's rotating. Okay, so now with the auto wind guide, the operator doesn't have to pay as much attention to the hose going back on the hose reel. He'll still want to, he'll need to, because like again, they should be putting that hose back on the hose reel nice, neat, and orderly. That keeps the footage counter accurate. And like Matt said, that goes at a certain speed for each revolution. That travels a set distance on the scroll here. It's set up just pretty accurate when that hose is about in the middle of that hose reel. As it gets to the center of the hub, it gets off a little bit, or it's on the outer layers, it'll get off a little bit. If it does, there's this adjustment knob, so you can pull that out and turn it, and you can reposition this along the scroll here on this to line that hose back up properly on the hose reel. And then if you've got the pinch roller, I talked to you about the button push. If you need to loosen the pressure on this pinch roller, push that button. Now the pressure has gone off this. It's air pressure. Okay. It'll relieve that air pressure. Now, usually what I see when you're doing that is they just need to reposition, like the wrap is instead of it needs to be in the center on that rotation of the hose reel, maybe it's near the lip of it. The operator needs to get that back lined up properly. Hit that button, it'll release that pressure. Reset that hose as needed. You're ready to get going again. Hit that button. It's going to put the air pressure back on and keep that tension on the hose reel or the rotor hose. All right, the hose reel bearings. I don't know if anyone here has had to replace these bearings yet. If you're around these trucks very much, eventually you're going to. You're not going to enjoy this job, but it could be better than some, but it's not as easy as what it looks. If you have to replace these bearings, basically you have to take that whole hose reel assembly up off of this, and then all the hoses and wirings go right in the middle of the bearing here. So you're gonna have to take those out. To take those bolts out, remove this bearing and put the new bearing in. So you want to keep this bearing in as best shape as you can. Okay, so make sure it's greased. Make sure it's greased properly. Okay, there's the decal there. The grease, that's that decal there. So those two zerts on the left is for the bearings. 2 on the right is for the hose reel locks. Okay, how you want to, I want to get my pen out here. How you want to grease this, you got the 2 zerts. Do not use your air grease gun. Use your hand operated one, a couple pumps on each one. And you can see here, there's a line going there and you can barely see the other line there. Okay, a couple pumps of your grease gun. Now you've greased these bearings. Rotate it. A couple more pumps. Now you've greased these bearings. A couple more pumps. Now you've greased these bearings. So as you're greasing that, rotate that hose reel. That way you're going to grease all the bearings. You're not just going to grease a little bit. Again, don't use that as a brake. Use that as a lock. You hit that button, those locks retract. You can rotate this, pivot it. You stop it, hit that button again. These locks will extend, and those lock blocks will engage in the bearings here. All right, that's the bearings of the hose reel. All right, any questions on what we just went through there, guys? Okay. Oh, let's see. I just lost you. Hang on a second. Let me find you again. There we go. All right. I saw a few heads shake no, so take it we're okay.
Sorry,
So
I have a
what's the-
question.
Yep, go ahead.
It was about, not really about today, but I just, no, because we have a truck in the shop where the gallons per minute is just fluctuating, the reading. I was just wondering where it measures that reading.
That is actually a math equation.
Okay.
Yeah, it knows, the system knows. Let's see if I remember right. You know the rotor pump, you know what it looks like inside. You've got the piston, you've got the rod on the other end. So one side is 3 gallon and then the rod end is 2.8 gallons. So it knows how much water's in there. And there's a timer in there, so it knows, okay, I just pushed out 3 gallons. Okay, I just pushed out 2.8 gallons. So that is actually a math equation. So
Okay.
if that is off, and something else is missing there, because like I said, that's a math equation. Are you pushing air? That's when I see those get off. If it's pushing air, it's thinking, that when you're pushing air, it's going to go faster. And then also you're not really, you're going to see that gallons per minute go way up.
Go way up, yeah. I've seen it like fluctuate up and down. It's just not really holding like a position. You know, I've seen it a bit, but it just came in as a complaint that, came in from a different location saying that, that it was fluctuating, that the gas per minute was fluctuating. I don't know, a couple guys were saying rotor pump.
Is it a 2100i?
It's not an I, no.
Okay. On a plus.
I think it's a plus. Yes, yes.
Okay. Those are controlled just a little bit different. That one, those are. Let me share my screen and maybe I can. I don't have the real sensor here, but maybe I can explain it a little bit. But on those, there's a sensor.
Oh, the proxy sensors.
Yeah, the proximity sensor, and there's a piston in there.
Yeah.
So it gets to the end of that stroke. That sensor sees that. As soon as that turns on that input, and it says, okay, the end of the stroke, we need to turn off that directional valve and turn on the other one. When it leaves, it knows it's the end of that stroke.
Yeah.
So you have that. Are you getting a good that? Then again, also, are you pumping water? Are you got a good water supply? So a couple things to look at.
Yes, yes.
So, but like I said, that's actually a math equation. Both circuits, both trucks, it knows. Okay, I just pushed out 3 gallons. I just pushed out 2.8, and it just looks at the time and calculates that. I did that. However many strokes.
Yes.
The whole number of strokes is now I pushed out 80 gallon or 50 gallon, 30 gallon, whatever over time. So that's a math equation, and you're not adjusting that at all. So it's just the matter of time and seeing that sensor where it's at.
Where it's at. Yes, yes.
But,
okay, that sounds
but with that, I think the first thing I would look at is your water supply there. If it's pushing air, it's going to throw that off.
Okay, okay.
And actually, if you catch this, if you're on the plus, if you get your low water alarm going off, it actually turns off that gallons per minute reading because it doesn't know if it's doing water or air.
Or air, yes, yes.
So you get the low water alarm, that value goes away, it goes to nothing.
That goes to nothing. Yes, yes.
Yeah.
Okay. Yeah. I guess some direction at least,
Yeah.
No, I appreciate it. Thank you.
Yep, no problem. Any other questions, guys? If not, it's time to call it for the day. We'll see you guys tomorrow at the same time, 9:00 our time anyway. So with that, thanks guys. Hopefully you got some good information today and yesterday, but we'll see you in the morning. Thanks guys. Tomorrow.